Right, to start chapter 13 off over trig identities, I want to go over how we are going to use this help sheet. So if you have not looked at this yet, you are really going to want to familiarize yourself with it because we're going to be using it this entire chapter. So to start with, the first couple of things are review from the last chapter. So for example, this is stuff off of our unit circle, and I just put the first quadrant on there since basically these values repeat all the way around, just the signs are changing. So again, this would be the 30 degrees, 45, 60, and 90. So if we are trying to find exact answers, this could be helpful to us. Also, review from the last chapter is how we are defining sine, cosine, and tangent. So remember when we have our right triangle, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So again, if we're trying to find exact values, we'll need to know this information. Okay. Also, review from the previous chapter are these reciprocal functions. So we talked about how sine was the same thing as 1 over the cosecant, and the reverse is true where the cosecant is equal to 1 over sine. So these are also listed as our trig identities. Quotient, again, we should be familiar with the fact that tangent is equal to sine over cosine, which means that its reciprocal, cotangent, would be equal to cosine over sine. Okay. So the new stuff is basically the rest of this sheet. So we have the Pythagorean identities, which we're going to use to help us solve and simplify. Now the cofunction and the negative angle identities, sometimes referred to as the odd-even identities, we're not going to use a lot in this class. That's more when you get to pre-calc, but I wanted you to see them. So we would use these if we were trying to find exact values. And then later in the chapter, so section 3, we're going to be doing the sum and difference. And then section 4 is the double and half angle identities. Okay. And then this little chart down here is just to remind us when our trig functions are positive. So if it helps, you can use the phrase all students take class to help you remember which trig functions are positive in which quadrant. So for example, all of our trig functions, our exact answers, would be positive in quadrant 1. In quadrant 2, the sine and then its reciprocal cosecant are positive. Everything else is negative. In quadrant 3, tangent and its reciprocal cotangent is positive. And then all the other trig functions would be negative. And then quadrant 4, cosine and its reciprocal secant are the only trig functions that are positive. All the others are negative. So to start the chapter, we are going to be focusing on using this piece at the bottom. And then at the top here, we are going to be using our reciprocal functions. We'll need these, the SOHCAHTOA information, and then the quotient and Pythagorean identities. So again, we're going to start that in the first 2 sections of this chapter. Now, a couple of things that are not on here, but that we are allowed to assume. I want to make sure we cover that as we start simplifying. Let's see. Sorry, guys. Trying to find a... There we go. So I'm just going to kind of do a separate note thing. So with the reciprocal functions... So I'm just going to do reciprocal. If I have sine theta equal to 1 over the cosecant of theta, I can also assume that sine squared theta would be equal to 1 over the cosecant squared theta. Okay. Or if I had sine cubed theta, then its reciprocal would be 1 over the cosecant cubed theta. So we're allowed to make that assumption for all of these. Okay. So we just want to make sure that we're keeping the power. Over here for the quotient one, so again, quotient. So if I have tangent theta equal to sine theta over cosine theta, then I'm allowed to make the assumption if I had the tangent squared theta that this would be equal to sine squared theta over cosine squared theta. Okay. Oops, sorry guys. Okay, so again, we're allowed to make this assumption. Same thing, if this was a 3, then these powers would be 3's. And that's true for cotangent as well. And then for the Pythagorean identities, so I'm just going to write it on here so that way you guys can, I'm not trying to flip back and forth between those pages because my area is a little too small for that. So if we start with that first Pythagorean identity, the cosine squared theta plus sine squared theta equals 1. We are allowed to rearrange this. So for example, let's say that I wanted to solve for cosine squared. To do that, I would subtract sine squared over, and that would give me cosine squared theta equals 1 minus sine squared theta. Or let's say I wanted to get my sine squared alone, then I can subtract that over. So we can make the assumption that sine squared theta would be equal to 1 minus cosine squared theta. Okay. So these three are equivalent to each other. Now you're only going to be given this one on your sheet, but as we start simplifying, if we need to rearrange, so let's say I saw this on my paper, well, anytime I see 1 minus sine squared, since it's equal to cosine squared, I'm allowed to replace it with this. So that's going to be really helpful to us when we start simplifying our trig identities. And that, again, is going to go for all of them. So if I had that 1 plus tangent squared theta equals secant squared theta, again, I can rearrange this. So let's say that I wanted to solve for tangent, then I would subtract the 1 over. So that means that tangent squared theta is equal to secant squared theta and then minus 1. It's also true if I wanted to get the 1 by itself, that I can subtract that over. So in this case, 1 can be equal to tangent squared theta, secant squared theta, and then minus tangent squared theta. Okay, so again, all of these would be equivalent to each other. And we can go through that exact same process for that last one. So cotangent squared theta plus 1 equals the cosecant squared theta. So if I wanted to rearrange by getting the cotangent by itself, I would subtract the 1 over. So cotangent theta is going to be equal to cosecant squared theta minus 1. Or if I wanted to get 1 alone, I would subtract that cotangent over. So 1 would equal the cosecant squared theta minus cotangent squared theta. Okay, so again, all of these things would be equivalent to each other. And again, that means that let's say that we're simplifying and we see this part right here, I'm allowed to replace this whole thing with what it's equal to. Okay, and again, as we start simplifying, that should make those things easier. So we will need to know this information for the first 2 sections in this chapter when we get into simplifying trig identities.